Section 4.8, Triangles and Coordinate Proof. First of all, coordinate proofs use coordinates or points such as x, y, and also some algebra to prove concepts such as two angles are congruent or a triangle is isosceles. First of all, though, we need to look at how to position and label a triangle. So the directions for this problem we're going to take a look at say position and label a right triangle x, y, z with leg x, z, d units long on the coordinate plane. So I have my coordinate plane here, and some things to remember as we do this are listed down here below. First one, use the origin as a vertex or center of the triangle. So this is the origin, the spot 0, 0. So we want one of our corners of our triangle, the vertices, to be on that spot because we know its x and y coordinates are both 0. Then the step 2 is to place at least one side of the triangle on, it should say on a axis, because either the x or the y axis, it would be nice if you could get your triangle sides to be along that, and sometimes you can get both sides, one here and one here in the case of a right triangle. Step 3, keep the triangle within the first quadrant. Now if you remember back to algebra, our coordinate plane is divided into 4 coordinates. This one right here, where both the x and the y coordinates are positive, is the first quadrant. So we want our triangle to be within this area, if at all possible. And step 4 is to use coordinates that make computations simple. So keeping it to using the origin of 0, 0 and having simple numbers will help you when you go to actually compute your answer. Now getting back to this problem, since we want it to be a right triangle, this is going to be very nice. If you can envision a right triangle, it would be able to fit right in here if we needed to. Maybe we'd have to flip it around or whatever, but we could get a right triangle to fit right in here. So we'll draw that line there, and we'll also put in our symbol for a right triangle there, so we remember that is 90 degrees. And we know that this vertex then has the coordinates of 0, 0. And we want this triangle to be called x, y, z, so let's say this is x here, and this is going to be y, and this point over here will be z. But we need to figure out our coordinates for x, or no, for z and for y. This does also tell us in our directions that we need leg x, z, so that's this leg right here, to be 9 units long. If it is 9 units long, or d units long, and sometimes we're just going to have coordinates that are all letters, but in this case, we're going to have an x of d and the y then of 0. It's d. If it would have been 9, like I said, it would have been 9 and 0. But in this case, with a little bit of algebra in here, it's not giving us an exact unit in numbers, but it's telling us a variable that's going to describe the length of side xz. Well, that's great for this coordinate. Now what about y? Do we know anything about the coordinates for y? Yes, we do. The x coordinate is going to be 0. So we're going to fill in a 0. Do we know the y coordinate? Do we know how far we had to count up here? Nope. Did they say it was d units like it did here before? Nope. So we cannot assume it is d units that we go up. We have to give it another variable. So let's call it a. So there is how you position and label a triangle when you need to use it for coordinate proofs. complete Check Your Progress number 1. Example 2, we are identifying missing coordinates. So in this case, our triangle is already positioned, and we have to find out what our x and y values are for each of these points. For this example, we have a right triangle here. Our Q, point Q, I think you can see is at the origin, so 0, 0. Now with this one, it gives us no information really about the distance that R is from Q, or it doesn't give us the length of QR, so we're going to have to use a variable to describe that distance. We can pick any variable. Let's pick D again. Now as far as our y coordinate, we're not going up or down any. We're right on 0 here, so we're going to put in a 0. Now for our S, point S here. X coordinate, it's right straight up because we're told it's a right angle here, straight up from point R, so our X coordinate is going to stay the same. Visualize this. If this was like 4, if D was 4, then it would also be 4 for the x coordinate of point S. We do not know how far we go up, so we can choose another variable to describe our y coordinate. Let's say it's F. Another problem to look at for example 2, finding the missing coordinates for this isosceles triangle. X again is going to be 0 and 0. Z, well, that can be D and 0 again, but now it gets a little trickier for Y. Since this is an isosceles triangle though, we know that point Y lies halfway between X and Z. Since the distance between X and Z is D, half of the distance between X and Z would give us our X coordinate for point Y. So we can write this as D over 2 for our X coordinate there for Y. Make this a little bigger. And then as far as our Y coordinate for point Y, we can give it any letter we like. We'll give it the letter F. Now you can complete Check Your Progress number 2. Example 4, classify triangles, and here we are going to be using a coordinate proof. So here are the directions. Write a coordinate proof to prove this flag contains an isosceles triangle. The flag is 4 feet by 6 feet, and point B bisects the bottom of the flag. So I've drawn in our dimensions, and here I will put our little congruent slashes. So B is bisecting or cutting this bottom side of the flag in half. Means we have 3 over here and 3 over here. But what I also want us to think about is visualizing this flag being set on a coordinate plane. And let me draw in with pencil. So pretend or envision this as being the y-axis and this side as being the x-axis. So if we do that, what is this point over here? It is point 0, 0. This point up here, A, has the coordinates of 0, and it was 4 tall, so 0, 4. Oops, now I need the 4 in there. Point C, its coordinates are going over 6 and up 4, so 6, 4. And this bottom corner of the flag has coordinates of 6, 0. How about point B? It divided this side in half, so this would be at 3, 0. It wants us to prove that this is an isosceles triangle. In order for it to be an isosceles triangle, we need these two sides to be congruent. Put the double hash there. So in order to prove that, I can use these coordinates and substitute them into the distance formula to see the measure of AB and CB and see if they are equal. So for AB, we would have 0 minus 3, that's squared, plus our x coordinates of 4 minus 0, or our y coordinates of 4 minus 0 squared. And that would be 9 plus 16, which would be 25. And then finding the square root of 25, we find that AB has a measure of 5. Now going and looking at CB. The distance between these 2 points, we could take a look at 6 minus 3, squaring that and adding it to 4 minus 0, and squaring that. So once again, we have 9 plus 16, which would be the square root of 25, which would make CB equal to 5. So yes, those two sides are congruent, and we have an isosceles triangle. Complete Check Your Progress, number 4.